So I will start with a brief introduction, and then I will move to methodology, a statement of the problem, and then I will share our results and conclude with some recommendation and future research. So circular economy is a sustainable development model that replaces the end-of-life concept with reducing, reusing, and recycling by creating a closed-loop system that minimizes waste and extraction of raw materials. Therefore, considering that construction industry is one of the largest consumers of raw materials, and it also produces significant amount of waste, there are a lot of opportunities for this industry to adopt these principles to benefit from this model, both environmentally and from economic aspects. However, adoption of circular economy principles have its own challenges for the built environment. For example, there are significant design changes that are required, and there is also uncertainties about the quality of recycled and reused materials. There is also lack of understanding and knowledge and different levels of knowledge among various stakeholders. And there is also economic uncertainties, and development of new business model is required. And most importantly, the supply chain is complex, and there are inadequate communication and collaboration in this industry. So in order to successfully apply circular economy principles, there is need for integrating the whole supply chain from supplier to architect to contractor and to the end of life cycle demolisher. So considering that this industry is fragmented and there are difficulties in sharing information, there is a need for integrating information through a information system, and currently the dominant information system in the construction industry is BIM. So it can provide information about materials and components that would lead to development of developing material passports that can be used for circular economy, and it can also improve the collaboration among different project stakeholders by providing a platform for information exchange, and it can also reduce errors and uncertainties during the design phase, and it can help for clash detections. So in general, it can integrate the supply chain, which is necessary for adopting circular economy. However, this digitalization and integration of information has its own challenges, and adoption of BIM has been slow due to these barriers. For example, there are technical barriers such as lack of familiarity with BIM technology, difficult access to the data, and interoperability and compatibility issues between different softwares that different stakeholders use. There are also social barriers such as lack of awareness or lack of interest, and there are also legal risks such as risks related to transferring data and data ownership. And there are also economic barriers such as increased cost of projects because of cost of hiring or training people to use BIM. So there is need for developing an information management framework to integrate the whole supply chain and successfully adopt circular economy. And because of the barriers that was mentioned, this research identified BIM-based frameworks designed for information management for facilitating these circular economy strategies. And also gaps and challenges and opportunities around this topic were identified. So about the methodology that was used, first a systematic literature review was conducted based on 662 documents that were gathered from Web of Science and Scopus databases, and search keywords and search terms that were used were circular economy and built environment and building information management. That included also building information modeling, and the map of co-occurrence of keywords were created as shown in figure 3, and as it can be seen, there are 5 clusters that were identified, including construction, industry, and BIM, which is the green cluster, and waste management, which is the red cluster, and life cycle assessment. These three clusters were the dominant clusters that were identified, and there are also circular economy and cities and urban development that were smaller clusters that shows that the number of research in these areas were fewer. And also in this map, the higher the number of co-occurrences are, the cluster are located closer. So it can be seen that there are gaps and there are distance between construction industry and circular economy, and construction industry and waste management cluster, and also life cycle assessment. So it shows that there are limited research in this area, and there are gaps that needs to be addressed. So in more details, because the focus of the research was about information management, it can be seen that also information management keyword is kind of separated from construction industry and circular economy and life cycle assessment. So it also shows the gap, and therefore the search terms were refined, and the focus this time was more on building information management and circular economy and waste management, such as construction and demolition waste. These keywords were added this time, and the second map of co-occurrences were created. Again, on this map, as it can be seen, circular economy cluster, which is the blue cluster, is separated from construction industry and information management cluster, which is the green cluster. So these distances again shows that a number of research are few in these areas, and there are gaps that can be studied further. So based on the second map that was created was based on 151 documents, and after reviewing these documents, 14 studies were identified that were using circular economy and BIM in their studies and have developed frameworks. And the most important findings from reviewing these studies were that only 2 frameworks considered all of the circular economy strategies in their framework, which are the first 2 studies, and most of the studies were about reusing materials and recycling materials. So most of the studies that were available so far were about challenges and opportunities of using BIM for facilitating adoption of circular economy, and only 14 papers focused on developing framework for adopting circular economy using BIM, and only 2 frameworks, as I mentioned, incorporated all of the circular economy principles, and about the life cycle stages that were considered through these frameworks, only 8 studies considered the whole life cycle approach. And it was also noted that a limited number of case studies were available for circular economy projects, and the number of demonstration projects are few, and none of the case studies incorporated all of the circular economy principles in just one project. So, in conclusion, for future research development of a common life cycle information management framework for facilitating the adoption of circular economy principles in the construction industry is identified as a gap, and it needs to be studied further. And also, most of the research were focused on reusing and recycling, so higher circularity strategies such as refuse, rethink, and reduce needs to be investigated further, because reuse and recycle are low to medium to low levels of circularity strategies. And for example, studies about refuse could incorporate abandoning a function if it is redundant. So in this case, there will be no extraction of raw material, so it will have higher circularity values. And about rethink, it is about making product use more intensive by, for example, sharing a product or developing or designing a multifunctional product or material. and reduce is about increasing efficiency in product manufacturing or use by consuming fewer natural resources. So there can be further studies about these principles in construction industry. There's also education and skill gaps that were identified as an area that was not studied much in the current literature, and it can also help industry because there are skill gaps about circular economy and BIM, and also further case studies and demonstration projects could be investigated further, and they can be used as a reference to be a guideline, and also they can encourage industry to adopt circular economy further, and it can also respond to the education and skill gaps that currently is a problem. And finally, it was noticed that most of the research were about buildings, circular economy in buildings, and a number of research about circular economy on infrastructure projects are limited. So having information exchange among these two sectors could have various benefits, and could increase the opportunities for adopting circular economy in both sectors. So here are the references, and thank you so much for your attention. This is the QR code for our website for our group in UCD.
Okay.
Thank you.
Thank you, Sadaf.